Hi everyone. So in this video we're going to learn the response of overdamped second order system for unit step input. So initially, as in the previous lectures, we are starting with the transfer function of a second order system, that is C of s by R of s equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. We're going to give a step input to the second order system, and which is overdamped. Overdamped means the value of damping factor theta will be greater than 1. Okay, so in that case, the two roots of the equation, that is the roots of the denominator polynomial, when it is getting to 0, that is our characteristic equation. Okay, the two roots will be s and sb will be minus theta omega n plus or minus omega n root of theta square minus 1. Okay, and if you are taking the minus sign outside, okay, minus is taken outside, and we can also written as theta omega n plus or minus omega n root of theta square minus 1. Okay, and here we are introducing a new term, that is s1 and s2, such that the s1 represent, okay, the term s1 represent one of the term here, that is theta omega n minus omega n root of theta square minus 1, and s2 means theta omega n plus omega n root of theta square minus 1, and this s1 and s2 is like that. S1 is equal to minus sa and s2 is equal to minus sb. Okay, that is if if you are taking that minus theta omega n plus omega n root of theta square minus 1, then s1 will be minus of that sa, that is minus of that sa means theta omega n minus omega n root of theta square minus 1. Okay, so we can simply write the denominator as s plus s1 into s plus s2, like that. Okay, that is the roots are s and sb, that is minus s1 and minus s2. So here we are going to replace the term, that is denominator term, with the s1 and s2. Once again, s1 is theta omega n minus omega n root of theta square minus 1, s2 is theta omega n plus omega n root of theta square minus 1. Okay, so omega n square divided by s plus s1 into s plus s2, and we know that we are giving the step input, so r of s will be 1 by s. So the equation comes, that is response in s domain comes like that, that is c of s is equal to omega n square divided by s into s plus s1 into s plus s2, and we are going to take the Laplace inverse of the c of s to obtain the response in time domain, that is c of t. So by partial fraction method, the c of s can be split into three terms. The first one is a by s, then plus b by s plus s1 plus c by s plus s2. Okay, both the values s1 and s2 we have already written in the first slide, and the a can be found by using our normal methods, that is you can use any methods of solving this a, b and c, just cross multiply with these terms and equating to omega n square. Okay, likewise you can use any method. So here we are using a can be found using the equation, that is we are going to multiply the denominator term s with the c of s, that is s into c of s at s equal to 0. Here the root of s is 0. Okay, so if I am multiplying this s and s get cancelled, and we know that, and if you are applying this s equal to 0, we get omega n square by s1 into s2. Okay, and just we are substituting the value of s1 and s2 here. Okay, s1 and s2, and by multiplying the terms we will get it as theta square omega n square minus omega n square into theta square minus 1. Okay, just we are multiplying it with. Okay, and we know that by opening the bracket, the theta square omega n square will get cancelled, and we get omega n square divided by omega n square, that is equal to 1. Okay, very simple step. And b can also be obtained by using the method, that is we are multiplying the term s plus s1 with our entire transfer function c of s at s equal to minus 1. Here the root is s equal to minus s1, sorry, s equal to minus s1. Okay, s equal to minus s1 you can see here, and if you are multiplying with the term s plus s1, the s plus s1 is get cancelled, and we will get it as omega n square by s into s plus s2. and if you are substituting for s equal to minus s1 here, it becomes omega n square by minus s1 into minus s1 plus s2. And here just we are substituting the value of s1 and s2 in this bracket, okay, in the closed brackets. So this is minus s1 and this is s2 plus s2, okay. So this theta omega n will get cancelled, and we will get it as minus omega n square by 2 omega n root of theta square minus 1 into s1, okay. And this omega n get cancelled, and at last the b will be minus omega n divided by 2 root of theta square minus 1 into s1. And c can also be obtained in the same procedure, that is c of s into s plus s2 at s equal to minus s2, okay. And s plus s2 terms are cancelled, so we will get it as omega n square by s into s plus s1 at s equal to minus s2. And we are substituting for s as minus s2, we will get it as omega n square by minus s2 into minus s2 plus s1. And substitute the values for s1 and s2 in the bracket, okay, in the bracket, that is this is minus s2 and this one is s1. So this theta omega n get cancelled, and we will get as minus 2 omega n root of theta square minus 1. So it becomes minus into minus becomes plus. So here omega n square divided by 2 omega n root of theta square minus 1 into s2, and omega n get cancelled, and at last we will get it as omega n by 2 root theta square minus 1 into s2, okay. So this is the value of c, and you have to substitute these values in the c of s equation. And for obtaining the response in time domain, that is c of t, we have to take the Laplace inverse. The Laplace inverse of 1 by s minus this equal to sign is not here, so Laplace inverse of 1 by s minus omega n by root 2 root theta square minus 1 into 1 by s1, okay. That is b into 1 by s plus s1 plus omega n by root 2 root of theta square minus 1 into 1 by s2, that is instead of c into 1 by s plus s2, okay. Instead of this b and c, we just substitute these values, this b and c values. So c of t, okay, what will be the value of c of t, okay. So c of t 1 by s, the Laplace inverse of 1 by s, we know that it is 1, and this omega n by 2 root theta square minus 1 is constant, and s1 is also constant. So the Laplace inverse of this 1 by s plus s1, we know that it is minus e raised to minus s1t, that is 1 by s plus a. Laplace transform of Laplace inverse of 1 by s plus a is e raised to minus at, okay. So like that, Laplace inverse of 1 by s plus s1 will be e raised to minus s1t, okay, e raised to minus s1t. Then minus omega n by 2 root theta square minus 1 into 1 by s2 into e raised to minus s2t, okay. And c of t, we are just taking outside the value of omega n by 2 root theta square minus 1. We will get it as e raised to minus s1t by s1, then minus e raised to minus s2t by s2, okay, where s1 and s2 are our solutions, okay, as we have previously written the terms s1 and s2. So this will be the response of a second order system, that is second order overdamped system for unit step input, that is 1 minus omega n by 2 root theta square minus 1 into e raised to minus s1t by s1 minus e raised to minus s2t by s2, okay. And if you are giving a step input of amplitude a, we have to multiply with the term a here, and this is the waveform we are obtaining. This is the input waveform, step input, and this is the output waveform for different value of theta, that is greater than 1. For 0, 1.5 it will be like that, for 2 and for 3, okay. I hope all of you understand the response of an overdamped system, second order overdamped system well. So thank you.